Right, these questions are an extension really of proportional questions and equation of a straight line, where what we're doing is we're taking a relationship which is a quadratic relationship, x squared plus b, which means that when we plot that we would expect to see a U-shaped curve or an inverted U, and rather than plotting the x value against it, by plotting the squared value against it, we actually turn the graph into a straight line, and then we can use our knowledge of how to find the unknown parts, the gradient and the intercept of a straight line, to estimate the equation of the curve. So these questions tend to come up right at the back end of a paper, usually paper 2. So let's see what the little trigger points are. So during an experiment, the value of variable y was found for different values of x. The results are recorded in the following table. So a table there linking x against y. On the graph paper below, plot the values of y against the values of x squared. So that's the first thing to look at is, oh, hang on a minute, it's not y against x, and you have to read that carefully. Because if you were to plot 190 to 170, then you wouldn't end up with a straight line, you'd end up with a curve. So we're not plotting against x, we're plotting against x squared. 1 squared is 1, 4, 9, 16, 25. So it's really important you spot that trigger there. So x squared is 1, y is 190. So we're going up on this scale 5 in 10 jumps, so each little square is a half. So 1 will be 2 squares, and in this direction we're going up where each 2 squares is 10, so 10, 20, 30, 40, 50. So 190 will be 2 squares in and 2 squares down from 200. Mark it with a cross. Then we're not going to do 2 170, we're going to 4 170. So 2 squares in from 5, that's 150, 160, 170. 9 is 130. So we're going to go 2 squares in from 10, and that's 150, 140, 130. 16 is 70. So 15, 16 is 50, 60, 70, and 25 is 0. So you can see there that we haven't got a U-shaped graph, we have actually got that straight line. And you can see it's sloping downwards, so it's going to be a negative gradient. Now these are approximate, so it's not going to fit exactly, so we're pretty much working on the line the best fit, but you can see that it's pretty close. So that would get you the 2 marks for that. Part B, it is known that y is approximately equal to ax squared plus b. So y ax squared plus b. Use your graph to estimate the values of a and b. So we're treating it as a straight line. Because we've plotted that x squared, that means that we can use that graph now just like if that was an equation of a straight line to work out a and b. B is the intercept on the y-axis, so straight away we can see b is 200. So that means, therefore, y equals ax squared plus 200. So all we need to do now is work out what a is. Now there's 2 ways that you can do this. You can either use the graph draw a triangle on it to find the gradient, or you can choose a pair of values from the table and solve the equation. I'll do it both ways for this particular question just so that you can see what I mean. So we can either, so if I take the graph, and when you're trying to find the gradient of a graph, you want to choose some points on the graph where you can see, you can easily read off. So I can easily read off that's 160, and if I go to that point there, I can read that off as well. So this distance is 50 and 10, 60, and this distance is 5, 6, 7.5. So we can either, so for A, we can either use the graph. The gradient is 60 over 7.5, which is 8. It's a downhill slope, so the gradient is negative 8. So therefore y is approximately equal to minus 8x squared plus 200. Or the other way of doing it is to pick a value. So when x is 1, y is 190. So 190 subbing in is going to be a times 1 squared plus 200. So 190, 1 squared is 1, is a plus 200. Get the a in its own, we need to get rid of plus 200, take 200 off each side. A will be negative 10. So therefore y would be minus 10x squared plus 200. Now either of those would be correct, which you may think is a bit weird because one is giving us a negative 8, one is giving us a negative 10, but it's an approximation. We're approximating a quadratic graph onto a straight line. So it doesn't matter which of those methods you choose, you will get the marks. Let's have a go at another. So the data in the table was recorded during an experiment. Results were recorded for the two variables x and y. Again here you will see that it's the graph of x squared that we want to work out. So we're going to plot 1, 4, 9, 16, 25. The units in this case are going up 20, 40, 60, 80, 100. So each little square is 20 on that axis, and each little square is a half on that axis. So 170 is going to be 1 in 100, 20, 40, 60, 70. 4 is 320. So there's 300. 4 is 2 in 320. 9 is 575. So 2 in, that's 500. 20, 40, 60, 80, 75. 16 is 925. So that's 950. So that's 16, 25, and 25 is 1370. So again, you can see there that those points are lying broadly on a straight line and not on a curve. So if we join those up, like that, It's known that the graph is approximately equal to ax squared plus b. Use your graph to estimate the values. So from graph, B will be where it crosses the y-axis. So it's 120. And A, if we go for the gradient method, I'm going to pick, let's go from there to there. So in this direction we've gone 5, 6, and in this direction we have gone 10, 20, sorry, what are we going up in? 20, 40, 60, 80, 100. 20, 40, 60, 80, 100, 20, 40, 60, 80, 200, 20, 40, 60, 80, 300. So we've got 300 in that direction. It's an uphill slope, so the gradient is going to be positive. So A will be the vertical 300 divided by the horizontal, which is 6. 300 divided by 6 is 50. So y is 50x squared plus 120. Again, you could have done that by picking a pair. Easiest one to go for would be x is 1, y is 170. You've got a slightly different answer, but both would be acceptable. The data in the table is recorded during an experiment, so you can see how repetitive these questions are. Results were recorded for the two variables x and y. On the graph paper, plot the values of y against the values of x squared. So again, it's against x squared. You could get a question where you'd be plotting a cubic, which would be x cubed, and turning that into a straight line. But most of the time, these questions come up, it's squared. So we're going to square those. 1, 4, 9, 16, 25. Let's check the units here. Each little square there's a half, same as the other questions. And this one, 2 squares is 10, so it's going up in fives. So 1 is 31. So 2 in, that's going to be 25. 30, just above that one. 4 is 52, so 2 in 50, 55, just underneath. 9 is 87, so that's going to be 75, 80, 85, 90. 16 is 136, so that's going to be 125, 130, 135, just above that one. And 25 is 199, which is just below 200. So those are the points. Draw on your line. It is known that y is approximately equal to ax squared plus b. B is just the y-intercept. It's going to be 25. And then we'll calculate the gradient. It's an uphill slope, so it's going to be a positive gradient. So if we go from there to there, this distance is going to be 10, 5, 10, and this distance, so each little square is 5. So it'll be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. So A is the gradient, which is 70 divided by 10, which is 7, is uphill, so it's positive. So therefore y equals 7x squared plus 25. So hopefully you can see that once you've spotted that's your trigger, square those, it's got to look like a straight line. You should be on pretty safe ground. The only question I found that was slightly different from those was this one. The diagram shows the graph of y equals bc to the power of x. So that is in fact y equals b times c to the power of x. So the only thing that's to the power of x is the c value. So it isn't a straight line, it looks like that. And what the question is asking is use the graph opposite of y equals bcx to the power of x to find the values of b and c. So this one, we can't find the gradient. What we have to do is find some points on the graph to use. So the easiest one here is this one. So that has got the coordinates x is 0, y is 2. And then 1 is always the next easiest one to use. So that point there is x is 1 and y is 5. So what we're going to do now is use those pairs in this equation to find the missing values. So using 0, 2, the equation becomes y is 2 equals b times c to the power of 0. Now this is a higher tier question, so you should know from indices that anything to the power of 0 is 1. So that means that 2 equals b times 1, so b equals 2. So that means that our equation now is y equals, and I know that b is 2 times c to the power of x. Now I'm going to put my next coordinate pair in, which is 1, 5. So when y is 5, x is 1. So y 5 equals 2 times c to the power of 1. So by choosing the x coordinate of 1, anything to the power of 1 is just c. So that means 5 equals 2c. So therefore c equals 5 over 2. So therefore my equation is y equals b, which is 2, c 5 over 2 to the power of x. You can't cancel those 2's, you might be tempted to, because that one is within that raised to the power of x part. So that's as simple as you can get it. You could write it as 2.5, but in algebra we tend to leave things like that written as fractions. So that one was a bit different, but again, if you recognize it and think, right, well, I can read 2 points off, so I've got matching pairs of coordinates x and y, and then substituting those in, hopefully you'd make progress with that.